All right, hopefully you guys did okay with problem 12-61. I just wanted to show you a graph real quick of some points from the table if you didn't figure out how to use the x coordinates from what were already on the x-axis. Those are the ones you're supposed to use. And finding sign of those values, if you just did the decimal version, that's definitely appropriate here. And then for the third column, it was 1 divided by this middle column. So that's how we find all those numbers. And I just wanted to point out here, I plotted some of the points in like this pink pen that you can see, or purple pen. But every time we're dividing by 0, so 1 divided by 0, that really means undefined. So we're not going to have anything at those points for the inverse of sine. I'm sorry, for the reciprocal of sine, 1 over sine. So at those places, so negative pi on my graph, I just want to show you that there should be an asymptote there. It's kind of hard to sneak in here, but so asymptote, that straight line, straight down, that means there's nothing there. Also, that happens at 0, so nothing there. Just like tangent, we had asymptotes. So these two are going to connect. Oops, this pen's kind of not good. We're going to connect those as, you know, pretend I didn't quite make it there. But so those are going to keep going down forever. So we have this asymptote at 0 also. Then we also have one at pi from our table. So there will be another asymptote. We're never, oops, I'm a little off there, but you get the idea. So same thing here. It gets closer to those asymptotes, but never touches it. So it's kind of like we've got some curves happening here. They're like almost little isolated parabolas. And then we'll do one more. So that's another asymptote at 2 pi. So just want to show you what your graph should look like. And you're labeling this. This was called a cosecant. That's what this graph is here, cosecant. Okay, so moving on to question 12-62. So it asks here, is this a function, first of all? So the thing with the pinks here, if that is a function, remember a function is anywhere that there's only one output for each input. So like if I'm at 5 pi over 4, I only go to one value. So that happens every single time. Even when there's no value, that's okay. So this one is a function. So we'll say yes for that. And then what are its domain? Its domain and range. So if you look here, its domain is the x coordinates here. And actually everything worked except those places where we had asymptotes. So remember when we solved equations and we said, pi over 3 and then plus 2 pi n. We're going to do that same thing here. Or we can do that same thing here. So we're at multiples of pi is where it's not working out. So 0, pi, 2 pi, negative pi. So I'm going to say its domain is all real numbers, which is that symbol there. But x cannot equal pi n. That'll work there. So multiples of pi, you could also put, instead you can say 2 pi plus pi n. That would be fine. That's saying you're starting at 2 pi and going around the circle. Sometimes you could put a 0. As long as this first part is a multiple of pi, that's good. Or you're going to say that part. And then the range, if we looked back on our table or on our graph, that's the y. So it's going up and up forever. So actually the range for this is going to be infinite. So we'll say all real numbers as well. Except, oh wait, sorry, I just noticed on here that it actually never touches anything in between 1 and -1. So let's actually, we can say that it's all real numbers, but also, woo, sorry, that's what I get for doing this on a locker shelf. So we have everything except it cannot be between -1 and +1. So let's say, or there's a better way to say this. Actually, let's back up. Instead of saying restricted values, let's just say it can be everything bigger than 1 and everything less than -1. So y is greater than or equal to 1, or y is less than or equal to -1. And because it stops at those points, it does have values at 1 and -1, so we're going to include those. So sorry about that. That was kind of weird. But that's easier than saying everything except that range. It's easier just to say these two. So what are the intercepts of the cosecant graph is what we're focusing on. So any x-intercepts, well, there actually aren't any. Same thing for y-intercepts, there actually wouldn't be any of those either since there's an asymptote right there. So no intercepts at all for this one. Are there asymptotes? We just talked about that, yes. What are their equations? So that's actually like the same thing we talked about in the domain here. So yes, there's asymptotes, and it is at multiples of pi, but the equation could be pi n. That's its equation, okay? Multiples of pi. Describe the relationship between the sine and cosine graphs in sentences. Oh boy. So let's look at these here. We're describing what they are doing. So let's talk about the sine graph. So that was this one in pencil. It's kind of light here. So as sine gets closer to 0, the height is closer to 0, what happens to the cosecant functions there, I guess? Let's think about that. So when I'm close to 0 and sine, my cosecant numbers get either really big or really big in the negative direction, right? So we have that going on. So I'll put that over here. So as sine of x gets closer to 0, cosecant approaches infinity. Maybe we'll say positive and negative infinity there since it's technically going both directions. And when that happens, let's say this creates an asymptote at those locations. Okay, so that's not the best complete sentence going on, but it's going to work for us. So again, as sine gets closer to 0, its height gets closer to 0, the cosecant is actually getting really, really big in both directions. And then we have asymptotes, which is why it gets bigger in those directions, really. Okay, so that's it for number 12-62. So go on to the next question, and I want you to try to solve that without using your graphing calculator at all and just drawing circles or using the graph that we just made here and looking off of the graph.